Going to discuss about power system transients. Myself K. Divya, working as an assistant professor in Department of Electrical and Electronics Engineering at Jaishram Engineering College, Tirupur. First, in Unit 1, we are going to discuss about the introduction and survey. What are the types of transient? Depending upon the speed of the transient and the nature of the frequency, the transients are categorized into two types. In this, first we'll discuss about speed of the transients. Based on the speed of transient, it is categorized into three. First, surge phenomena or extremely fast transient, which is caused by lightning and switching surges. It will travel with the speed of light. That means 3 into 10 power 8 seconds. Then, for an 150 kilometer, it generates a traveling wave which complete a one round trip in 1 milliseconds, which occurs in few milliseconds and it attenuated very fastly with few reflections. Second is short circuited phenomena or medium fast transients, which is caused by insulation failure or by fault, such as symmetrical or unsymmetrical faults. The time range between 10 to 100 milliseconds and it has 5 to 10 cycles, which is a slow phenomena compared to surge phenomena. Third is transient stability. It is also known as slow transients, which is caused by the reduction in power generation output and will lead to the mechanical oscillation of the synchronous machine and a change in the output of turbine. The time ranges between few milliseconds to 1 minute. It is mainly due to mechanical problems, so known as electrical mechanical transient, which leads to loss of synchronism. Next type is based on the nature of frequency. Based on the nature of frequency, it's again categorized into two, impulsive and oscillatory. First, impulsive. Impulsive, in this we are having three types of transient: low frequency impulsive transient, medium frequency and high impulsive transient. In low frequency impulse transient, the time will be at a range of 0.1 to 1 milliseconds and the frequency component will happen up to 5 kilohertz, which is a common transient and easily propagated. Next is medium frequency impulse transient, which has a duration of 50 nanoseconds to 1 millisecond. Then the frequency component is 5 to 500 kilohertz, which is not propagated easily as low frequency. Next, high frequency impulse transient. The duration is range below 50 nanoseconds and the frequency component is 0.5 to 5 megahertz. Then oscillatory transient. Again, it is categorized into three: low frequency, high frequency, and extremely high frequency. In low frequency, it is caused by power factor correcting equipments, which has 120 to 140 times high as the normal value. Then high frequency oscillatory transient, which is caused by inductive load cutoffs, which has few to 100 volts and several thousand amperes of current. Then is extremely fast oscillatory transient, which is caused by arching and bad brush motors. The rise and fall happens in nanoseconds. By using standard filters, we can remove this transient. These are the types of transients happens in power system. Then what is the role of study of transient in system planning? Mainly, the transient problem happens in one place will be penetrated to all the points from where it is originated. This is mainly happen both in industrial distribution system and extra high voltage transmission system. To study about the switching transient, it is very much useful in integrated systems. The most severe problems happens are due to lightning. So we want to detailedly study about the switching transient to find out the magnitude of the system voltage which causes severe troubles. In extra high voltage transmission lines, for economical reasons, we want to limit and control the switching surges. Based on the insulation, the cost of the transmission line is determined. So it's very important to study about the transients and its effects while designing the system. And a sudden reversal of polarity voltage can occur in the traveling waves, which also increases the switching surges. These are the above considerations or need to be analyzed while planning the overall system design. Next, importance of grounding. Grounding is important in power system, which used to provide safety, low resistance path for the fault current, and by tripping protecting devices quickly, it prevents the over voltages and causes damages and ensures the system stability and equalizing the potential. Thank you.